So in today's lecture we will discuss zero crossing method for FM demodulation. We have already seen that for FM demodulation we can either use this method, FM to AM conversion method, or we can use PLL method. The third one which we are going to discuss is zero crossing method. So in this method of FM demodulation, we use the concept that instantaneous frequency of the FM modulated signal is equal to 1 upon 2 the delta t, where delta t is time between two adjacent zero crossings. And this delta t is evaluated as t by n naught, where n naught is number of zero crossing in time interval t. So what I am saying here, that if this is your FM signal, as you can see that the frequency is varying as per the message signal. If this is your message signal, something like that. So this is your FM signal. So we choose a time interval t and we count number of zero crossing in that time interval. So for example, in this blue time interval t, there are n 1 or n naught number of zero crossings. So what would be the time interval between two adjacent zero crossing? T by n naught. Similarly, we can calculate for this time interval and this time interval, and it will give you the instantaneous frequency corresponding to that time interval. But the question is, how should we choose this time interval t? We should choose this time interval t in such a way that it is greater than 1 upon fc and it is less than bandwidth of 1 upon bandwidth of the message signal. Why do we choose our t in such a way? Actually, by choosing our t in such a way, it gives you at least some number of good number of zero crossing. If you don't satisfy this criteria, you might sometimes not get any zero crossing and it will give you wrong result. So choosing this t is logical, that we choose our t or time interval like this, and in this time interval we count the number of zero crossing and we see that instantaneous frequency is can be evaluated like this. And you know that instantaneous frequency of an FM modulator is of an FM waveform is kf mt plus fc. So if we pass this and if we remove this fc by DC blocker, the output will be proportional to mt. So if we know n naught by 2t, we know kf mt plus fc, and if we pass it through DC blocker, the output will be directly proportional to mt. So this is the concept which we use for the FM demodulation using zero crossing method. And the circuit we can realize this such type of zero crossing by using such circuit. First we pass our FM modulated received signal from the hard limiter. If you remember, the hard limiter generates the square wave and it preserves the zero crossing. So it will preserve the zero crossing and it will just convert this to square wave of some voltage. So this will be output of your hard limiter, and then we'll pass this output of this hard limiter through a pulse generator, which will give you a pulse at the rising edges. So either we can count both. For example, we can count the zero crossing if this is a signal. So we can either count 1, 2, 3, 4, or we can only count 1 or 2, because as you know that it is directly proportional, right? So the only proportionality will change. So we will only count the positive zero crossings. So that will not make any difference. So we generate such a pulses. So if we want to count in the time interval t how many number of pulses are there, how can we count it? We can integrate if we take its output as 1 and duration as tau. So what will be the output of, if we integrate it? So the output of this integrator will be tau plus tau plus tau. It means 3 tau. Correct? So if we integrate it in this interval of of t duration, we can also further subdivide it. So the output will be 3 tau by t, right? Or you can divide it by the tau also, not a big difference. It will give you 3 by tau. It will give you, excuse me, it will give you 3 number of, the output of this will be 3, right? So somehow it will give you the number of this n naught, correct? And then you can easily evaluate the frequency by dividing it with t. So you can also divide it by t here. So at the output of the integrator, you get the quantity which is directly proportional to FIT, which is equal to FIT, or which has a message signal and a DC component. So we pass it through a DC blocker and we get the message signal back. So this is the whole concept of your zero crossing detector. So this integrator is not always 0 to t, it will depend on the from here to here, right? So this is the interval, you can understand it as an interval, okay? So it will give you number of pulses in that duration, number of positive pulses, number of positive zero crossings. Okay, thank you.